Pre-Calc, welcome to the video on dot products of vectors. I'm going to start by defining what a dot product is. So a dot product, sometimes known as an inner product of two vectors u and v. Well, u is made up of parts u1, u2, and v is made up of parts v1, v2. The dot product u dot v is equal to u1 times v1 plus u2 times v2. We can kind of think of it like we are combining like parts, and in the end we're given a value that kind of says like what the whole thing has in kind of a direction. So I'm going to do a really brief example and then maybe give you a contextual example that'll help a little bit. Let's say this is u, and u is the vector 0, 3. And then let's say this is a vector v, and v is the vector 2, 0. The dot product, u dot v, is equal to the first piece of u times the first piece of v, plus the second piece of u times the second piece of v. So 0 times 2 is 0, 3 times 0 is also 0, and 0 plus 0 is 0. Well, why does this make sense? Because these two vectors do not share any common direction. This first vector has only like an upward direction, and the second one has only a rightward direction. So there's no common pieces. Another way that I think is maybe more applicable, because this is used in like force and work problems, but let's say you're playing Mario Kart, you're Princess Peach, and as you're driving, I don't like Princess Peach, actually. I like Waluigi, but we can debate that some other time. Anyway, you're driving and you see one of those little boost pads, right? And you know that you want to hit that boost straight on, because if you do, you're going to be flung forward at a really fast rate. However, if you get a little bit off to the side, like you'll still get some of a boost, but it's not quite as much, right? If you hit it dead on, your pieces are basically being added together and the force is bigger in that direction. If you're going off to the side, you'll still get some of it, but not quite as much. So that's a silly application of dot products. Let's talk about some properties of dot products. So the first is that a dot product is commutative, which means u dot v is the same as v dot u. The order of your dot product does not matter, which is good because, I mean, I hope that feels good to you. The second is if we take a vector and multiply it by 0, we're just going to get 0. The third is that we can basically distribute vectors like we would any other thing. So if I have vector u times v plus w, I can write that as u dot v plus u dot w. And last but not least, a vector multiplied to itself is going to be equal to the vector's magnitude squared. I want you to write that down, and then I'm going to quick go off to the side and show you. So this last one, let me explain. So let's say u is a vector with parts a and b. Well, u dot u is going to be part a times a plus b times b, because it would be like I have u and then another copy of ab. So this is really a squared plus b squared. Well, off to the side, what about the magnitude of this vector? We know the magnitude is the square root of component a squared plus b squared. So then look at these two. They're very similar to one another. Specifically, if I took this magnitude and squared it, I would get a vector multiplied with itself. u dot u. If you would like to pause the video and write down this problem, this is what we are going to start class with, finding the dot product of these two vectors. The second thing is the angle between two vectors. So if theta is an angle between two non-zero vectors u and w, then, so I'm going to start by just drawing this. Ooh, sorry, that was a bad line, but that's okay. Let's say this is vector u, and this is vector v, we'll say. So then theta is the angle between them. I can find theta by looking at the following. Cosine of theta is equal to the dot product of those two vectors divided by the magnitude of one times the magnitude of the other. U dot v is the dot product, and these are the magnitudes. Or if I want to just solve for theta, how would I get rid of cosine? I would say cosine inverse of both sides. So theta is equal to cosine inverse of u dot v over the magnitude of u times the magnitude of v. Once again, if you want to pause the video and sketch this drawing, that would be great because this will be our second example here. But pause it now because I'm going to go ahead to the next problem. This is another problem that, again, if you want to pause the video and write it down, that would be great. I am going to define orthogonal for you, although we're going to talk a little bit more about it in class. But orthogonal means perpendicular. And if you remember, perpendicular means two things that meet at 90 degrees. So we'll talk a little bit more about this after doing this example here, and those are the notes for 6.2.